மாணவர்களின் சிந்தனைகளை வடிவமைக்க SNS Institutions, மாணவர்களின் தனித்திறமைகளை மேம்படுத்த SNS Institutions, மாணவர்களின் சாதனைகளை போற்றும் SNS Institutions கோவை.
Hi, this is Major Kumar, Assistant Professor, Department of Electrical and Electronics Engineering from SNS College of Technology. Today we are seeing about some basic concepts, important one, types of gearboxes and then selection of gear unit. Last class we are discussing about gear wheels and then gear principles, advantages and disadvantages of all those things. Today class we are discussing about types of gearboxes and then selection of gear unit. And also introduction, the gear is a rotating machine that having a cut teeth which mesh with another toothed part to transmit the power. And also the gear device can change the speed, torque and direction of the power source. So these are all the basic things, and also the types will be the spur gear, helical gear, and then herringbone gear, and then rack and pinion, bevel gear, worm gear. So even though we have a lot of gearing mechanisms or gearing types, these are all the important one we are considering, this kind of things. So this will be spur gear. So just see the diagram. The tooth is parallel to axis of rotation and they transmit power from one shaft to another shaft, parallel shaft, used to electric screwdriver, oscillating sprinkler, and then wind up alarm clock and the washing machine and the clocks dryer. So that means we have in a two parallel shafts. So the power is transferred to parallel shaft only without any kind of change in speed. So it will give only in a parallel shaft. And also we have in two things, for example driver and then driven. So here for example we are using a odd number of gears, it will be the same direction of the speed, and even number of the gear will have a different kind of opposite speeds. And external spur gear, so in the external gearing the gears of two shafts mesh externally with each other and it will be shown in here. Okay, so the larger of the two wheels is called as a spur wheel, or a gear of the smaller wheel is called as a pinion. So that kind of things. And internal spur gear, for example, it will be a parallel, but at the same time it will be a aluminium and the internal gearing. So the previous one will be a external gearing or external tooth portion, but here the internal spur gear will be internal tooth portion. And the gears of these two shafts mesh internally with each other as shown in figure. The larger of the two wheels is called as annular, and the wheel and smaller wheel is called as a pinion. And this one will be helical gear. So the helical gear will be speed change and then direction of the movement. The teeth on helical gears are cut at angle at the face of the gear. This gradual engagement makes helical gears operate much more smoothly and quietly than spur gear. So if the angle of the gear teeth are correct, they can be mounted on the perpendicular shaft, adjusting the rotation angle by 90 degrees. So just imagine that we can easily change the direction of the gear also. So that will be helical gear. And rack and pinion gear, so the rack and pinion gears are used to convert the rotation from the pinion. For example, the linear motions. So the perfect example of the steering system of the many cars. So they are using, so this kind of rack and pinion system, when we are giving the steering, that steering will be give some kind of rotational movement. That rotational movement will be converted into linear movement of the pinion systems. And the straight and the spiral bevel gears. So this kind of gears will give 90 degree of a displacement of movement. For example, when we are transferring the power from linear into vertical into horizontal, or a horizontal into vertical, whatever it may be, we are using a spiral gears or a bevel gears. So this kind of gears are very, very important. So why we are using a different kind of gearing mechanisms? So we have in a lot of advantages on a gearing systems. At the same time, the gearing system will be give the high torque, low speed, or low speed to high torque. That kind of combination will be achieved with the help of gearing mechanism. At the same time, always the gear will not give any kind of a linear movement or a linear motion. At the same time, it should give some kind of different angle of movements. For example, I need a linear into rotational, or a rotational into linear. For example, high speed to low speed, or low speed to high speed, or a paralleling speed, or a sample speed, or high torquing applications, or a low torquing applications, and changing the rotation, for example 90 degree, 45 degree, or 100 degree, whatever it may be. We need some kind of different arrangements. That arrangements will be achieved, this kind of different gearing mechanisms. So this kind of gearing mechanisms will give, or it will produce the automation system will be 100% efficiently, and also the industry 4.0 or industry 5.0 needed that kind of things, or needed this kind of gearing mechanisms for achieving on the anything in the world. Okay, thank you. I hope you understood the basic concepts of a gear, types of gears. We will see next topic in another class. Thank you.
Contact and there is no interaction between rail and then train. So automatically when we start the bullet train, the entire train will lifted from the rail. We don't have any connection between rail and then train, right? So we have a magnetic elevation. Now the train is floating. So when we are giving the supply, it will act as a rotor and stator. The train is moving, highest speed. So this is the purpose. So because when we are connecting the bearings or when we are connecting the gear wheels, when we are connecting any kind of driving technologies, it will consume more amount of energy losses. In order to avoid that, we are making a some kind of relation motors. And also, it will consume less amount of power. For example, so when we are using different kind of motors in a cooling purpose, all the motors will consume more than 10 watts or more than 20 watts. But this kind of magnetic elevation motor, it will consume only 1 watt or 0.5 watts. So that's why we have different kind of applications, right? So like this, we have some other applications as well. For example, this is also some different kind of geared motor, DC motor, brushed motor, brushless motor, and also we have a fast mode, linear motor, so linear actuators, and then so we have a different kind of motor. So based on the structure, we have identified the motor types. So why we need this kind of information, or why we need this kind of knowledge means when we are going to service industries or when we are making to have any kind of robot will be a part, we need to identify the part. Before that, we need to know how the robot is working. So what are the motors they are using in robot? For example, robotic arm is not functioning. As a electrical engineer or as an engineer, you should aware of how the motor is working, how the robot is working, what kind of motor is used for robotic arms. So we need to know. So then only we can easily identify the motor type and then identify the motor parts. For example, some motor is directly run with the supply, some motors we need a driving systems. So if any combined in a driving system, the motor may be have a malfunction. Right? So that's why we need to know the motor types, motor working principles, how the motors are working. So when we need a motor driver or without driver, as well as a capacitor, without capacitor, three-phase induction motor means we don't want any kind of starting mechanism. But single-phase induction motor means we need some kind of additional starting winding. As well as synchronous motor means the synchronous motor is not starting a self-starting motor. Synchronous motor, we need to additional motor, we have a different kind of methods to start with synchronous motor. So synchronous motor is nothing but it will run the synchronous speed. NS equal to 120 F/p. But no other motor will run synchronous speed. All the motors will run below the synchronous speed, that is called as slip. Without slip, the motor will not run. But synchronous motor, we need to maintain the speed. 1500 means we need to make our rotor 1500. But it's not possible in a practical manner. So that's why we need some additional motors. For example, DC coupled motor, wound motor method, damper winding method. I think you studied it, right? So that damper winding will make that kind of corrections. Once synchronous motor will reach the synchronous speed, then the motor will not reduce their speed. It will continuously running the synchronous speed. So that is called as a synchronizing operation. I have a 10 motor, means the 10 motor should run 400 RPM without any kind of plus or minus delay. So definitely the industry will adopt that kind of synchronous motors. So we need to know the function and also the special type of motors. 80% of the special type of motors used in the robotic automation. So in robot, you don't need three-phase induction motor and single-phase induction motor. The robot will function some high accuracy with controllable manner. So we need some additional or some special kind of motor. That special kind of motor controlled by additional driving mechanism or additional drive systems. Right? So that's why we need to aware of special type of motor. So So, for example, in your semester, you are willing to do any kind of internship, try to do any kind of automation companies. So, you see the robots. So, how the motors are inbuilt the robots and how the motors are working, and also how the functions are there, right? So, that only you can understand. So, as an electrical engineer, when I am going to serve any industries, the industry persons are asking some motors are malfunctioning, and you can take things. But I don't know what is the physical structure of stepper motor or a 90 elevation motor, and how I can approach the service persons. Okay? We need to that kind of knowledge.